Alamak.
Assalamualaikum. My name is Muhammad Aziz Irfan bin Rosli. My student ID number is 2023665244.
My name is Irsyad Ushadi bin Ismu Fakrazi and my metric number is 2023657794.
My name is Muhammad Afif Danish bin Ahmed Subli and my student ID is 2023832574.
Assalamualaikum, my name is Muhammad Diman Farhan bin Mazlan and my number metric is 2023 at 59542 from AS1203C.
Introduction. What is meant by Maglev? Maglev is a short form for magnetic levitation. Magnetic levitation or maglev is a method by which an object is suspended above another object without any support other than magnetic field. The electromagnetic force is used to counteract the effect of the gravitational force. History of maglev trains. Early concepts. Early maglev concept emerged in the 1900s, but the progress was limited by material science and power challenge. Significant progress. The 1960s saw major breakthroughs with superconducting magnets and control system, leading to EMS and ADS technologies. First commercial train. Japan's Linimo 2005 marked the first commercial maglev, proving the technology's viability and spurring global investment. Maglev train versus conventional high-speed rail. Maglev is lower energy consumption, reduced friction, more expensive to construct and maintain, travel at very high speed, and minimal noise. For conventional is higher energy consumption, higher friction, lower construction and maintenance costs, slower than maglev train, and higher noise level. Fundamental principle. Picture number 1. Like poles repel while unlike poles attract each other. Picture number 2. One arrangement is shown here where the bar magnet is made to levitate. Maglev train. Technology used. Number 1. Use magnet to reach a really high velocity. Number 2. Floats about 1 until 10 cm above the guideway on a magnetic field. Number 3. The electromagnets run the entire length of the guideway which propel the train in the forward direction. Number 4. Once the train is pulled into the next section, the magnetism switches so that the train is pulled on again.
Next is key function of maglev train to high-speed operation. First is levitation. This involves lifting the train off the track using magnetic force, eliminating physical contact between the train and the track. This reduces friction, allowing for smoother and faster movement. Next is propulsion. Magnetic force are also used to push or pull the train along the track. This propulsion system replaces traditional engine and enable high-speed travel with minimal energy loss. Last, lateral guidance. This function keeps the train centered on the track. Magnetic force ensures stability and precise alignment during high-speed travel, preventing derailment. Types of maglev technology. There are mainly two types of maglev technologies used for the levitation purpose. First is electromagnetic suspension (EMS). Electromagnetic suspension use magnet to lift the train by attraction. The train stays close to the track using controlled magnetic force. Next is electrodynamic suspension (EDS). Electrodynamic suspension use magnet to lift the train by repulsion. The train needs to move first to create the magnetic lift. Explanation for electromagnetic suspension (EMS). Electromagnets attached to the train. These are the core components generating the magnetic field required for suspension. ferromagnetic stator on the track. These interact with the train's magnet to provide the lift necessary for levitation. Guidance magnet on the sides. This ensures the train stay aligned and stable along the track. Computer control current. A computer dynamically adjusts the electromagnetic current to maintain a consistent 1 cm gap between the train and the track, ensuring smooth operation. This picture shows an example for Maglev train from Germany using electromagnetic suspension technology. For electrodynamic suspension (EDS), Maglev train use supercooler superconductors under the train. Levitate about 10 cm. The force in the track is created by induced magnetic field in wires or conducting strips in the track. Naturally stable, require no feedback. Requires retractable wheels at low speeds. The picture shows an example of Maglev train in Japan using electrodynamic suspension technology.
Propulsion. The first one is the propulsion coils on the guideway. The guideway's sidewalls contain propulsion coils which are powered by a 3-phase alternating current AC supplied by a substation. This AC energizes the coils, creating a shifting magnetic field along the guideway. This magnetic field interacts with the superconducting magnets on the train, enabling its propulsion. The second one is interaction with the superconducting magnets. The Maglev train operates using onboard superconducting magnets, which are crucial for its movement. These magnets interact with the magnetic fields generated by the guideway coils. As the magnetic field in the guideway shifts, it creates attraction and repulsion forces with the superconducting magnet on the train. This interplay of forces propels the train forward along the track, enabling smooth and efficient motion without physical contact. Brake. The third one is braking. To brake, the system sends an alternating current in the reverse direction. This induces magnetic fields that oppose the motion, creating attractive and repulsive forces which slow down the object. This form of braking is energy efficient and smooth, commonly referred to as regenerative braking or dynamic braking in electric motors. Principle of lateral guidance. The principle of lateral guidance ensures that the Maglev train remains centered on the guideway. When the train moves closer to one side of the guideway, the superconducting magnet on the train interacts with the levitation coils on the guideway walls. This interaction creates a repulsive force on the side closer to the guideway, pushing the train back toward the center. Simultaneously, an attractive force is generated on the opposite side of the guideway, pulling the train towards the center. These combined forces work together to maintain the train alignment along the guideway, ensuring smooth and stable operation. Gap sensor. Continuous monitoring. The gap sensors continuously measure the distance between the superconducting magnet on the train and the levitation coils on the guideway. Dusty levitation. If the gap becomes too small or large, the sensor sends feedback to the control system. The system then adjusts the power supply to the levitation coils to maintain the correct levitation height, ensuring the train stays in a stable position. Ensuring stability, the gap sensors help regulate the train's position both vertically and laterally, preventing any undesired contact with the guideway and ensuring smooth and efficient operation.
Right now, I'm gonna tell you about challenges and limitation of Maglev trains. The first one is high construction costs. Maglev systems are more expensive to build and maintain than the conventional rail system. Second one is technological complexity. Maglev technology requires sophisticated engineering and maintenance, presenting challenges for implementation. The third one is limited infrastructure. The lack of existing infrastructure of Maglev train requires significant investment in new tracks and stations. Right now, I'm gonna tell you about advantages of Maglev trains. The first one is speed. Maglev trains can reach speed of over 300 mph, significantly faster than traditional trains or conventional trains. The second one is efficiency. They are more energy efficient than traditional trains, reducing fuel consumption and carbon emission. Lastly, quiet operation. The lack of friction between the train and tracks result in remarkable quiet ride for passengers. I'm gonna tell you about disadvantages of Maglev trains. The first one is high initial cost, expensive to build and maintain due to specialized infrastructure. The second one is limited compatibility, incompatible with existing rail system. The last one is high energy use, significant power required for levitation and propulsion. The future of Maglev transportation. Global expansion. Maglev technology is expected to gain wider adoption in coming years, with new system planned in various countries. Advanced system. Ongoing research and development are focused on improving efficiency, speed, and safety of Maglev train. Integrated networks. Future plans include integrating Maglev system into existing transportation networks, creating scamless travel options. The conclusion for magnetic levitation is a very advantageous technology with promising future scopes to be used in almost every field, although it is yet to be completely explored. Even the existing technology can significantly develop our life to a greater extent. That's all from us, and this is our references that we get information from. Thank you for watching, and Assalamualaikum.